Hello, geometry students. It is so nice to see you. We are doing our last notes for chapter 4. This is section 4.5, and the topic is dilation. Dilation. So dilation is also a kind of transformation. This whole chapter, chapter 4, is talking about different kinds of transformations. We've talked about translations, where you slide a figure, reflections, where you flip a figure over a line, rotations, where you rotate a figure, lines of symmetry, where we're going to draw a line through the middle of a figure to show its line of symmetry, and the last one here now is dilations. Dilations are different than the 4 other transformations that we've talked about, because in a dilation you do change the size of the figure. So for example, when we did a translation, we would move a figure in the coordinate plane, but it would not become larger or smaller. With a dilation, it's going to become either larger or smaller. Now, there are several ways to do dilations. One is measuring with a ruler, and that would be really hard to teach to you on the board here, because the length that I would show on the board would be different than the length that you would be seeing depending on what kind of device you were watching on. So I'm just going to do 2 examples on these notes, and they're going to be 2 examples that you can do in the coordinate plane. And then when we have our Zoom session, I'm going to show you how to use a ruler to do a dilation or to measure a dilation on your magazine picture. So we're going to be kind of looking at dilations 2 different ways. Both of them are legitimate. One of them we're going to be looking at more mathematically on the board here, and then the other way we're going to be looking at more in the context of a real world example, and I will show you that part during our Zoom session. So with a dilation, we always start with an initial set of points, and since we're only going to do 2 examples here, these are going to be a little bit longer. So I'm going to give us some points here. P is at 1, 2. Q is at 2, 2. R is at 4, negative 2. S is at negative 1, negative 3. So 4 points. And I'm going to say here that K equals 2. Now this number K, or this letter, stands for the scale factor. And you're not going to be actually quizzed or tested on this, but this is something good for you to know for future math classes. If this number is bigger than 1, our figure is going to become larger. If this number is smaller than 1, or between 0 and 1, I should say, then our figure is going to become smaller. So the cool thing about doing this mathematically is if we want to find the dilation of whatever figure this is with a scale factor of 2, it's super simple. All we have to do is take every coordinate that we see here and multiply by whatever our scale factor is. So if our scale factor is 2, all it means is that we get our image points, for instance P prime, by doubling every number that I had in my original pre-image point. So if our pre-image point P is at 1, 2, and I double both of those numbers, P prime will be at 2, 4. See if you can do Q prime. If Q is at 2, 2, what would Q prime be at? It would be at 4, 4. And if R is at 4, negative 2, R prime would be at 8, negative 4. And if S is at negative 1, negative 3, S prime is going to be at negative 2, negative 6. So let's go ahead and graph this and see visually what's going on. So I'm going to draw our X and Y axis, and I'm going to plot the initial points P at 1, 2, Q at 2, 2, and then R at 4, negative 2, and then S at negative 1, negative 3. And then I can connect these points here. Now, because this had a scale factor of 2, which is bigger than 1, I'm expecting when I plot my image points that I will have a figure that's bigger than the one that I started with. let's see if that happened. I'm going to plot P prime at 2, 4. And then Q prime at 4, 4. And then R prime at 8, negative 4. And S prime at negative 2, negative 6. Now when I connect these points here, you see that I still have the same shape, but now it is larger. It had a scale factor that was bigger than 1, so we've enlarged the figure. So this is a dilation where our image is larger than our pre-image. Okay, so we would call that actually an enlargement. If the scale factor is between 0 and 1, instead of calling it an enlargement, we call it a reduction. So let's go ahead and do one more example. Like I said, on this notes, we're only going to have 2 examples. On this example, what I'd like to graph is another polygon with a scale factor of 0.5. So let's write this down as example 2. I'm going to put J at negative 3, 4, K at 2, 1, L at 3, negative 2, and M at negative 5, negative 4. And for this problem, I'm going to say the scale factor is 0.5. If you want to, you can think of that as 1/2. Obviously, they're equivalent, so either way is good. All right, now, let's go ahead and take a look at this graph. Because the scale factor is 0.5, do you remember what it is I said that we needed to do to each point in our pre-image to get the point in our image when we're doing a dilation? What would I do with this number here, 0.5? What I want to do is multiply every coordinate by 1/2, essentially. So J prime would end up at negative 1.52. K prime would be 1.5. L prime would be 1.5, negative 1. And M prime would be negative 2.5, comma, negative 2. Now let's go ahead and graph these 2 figures and see how they compare. So in my original pre-image, J was at negative 3, 4. So I'm going to go 3 to the left and 4 up and put a J. K was at 2, 1. And then L was at 3, negative 2. And M was at negative 5, negative 4. So that would be my original pre-image. Now let's graph each of our image points after we took all of these numbers and divided them by 2 or multiplied by 0.5. So J prime would be at negative 1.5, 2. K prime would be at 1, 1/2. And you're really going to have to zoom in to see that, I think. L prime would be at 1.5, negative 1. Let me make that K prime a little bigger. I'm feeling guilty about that. There we go. All right, and then M prime would be at negative 2.5, negative 2. You can see now, if I connect these points, again, I do have the same basic shape, but it is smaller than my original pre-image. It is a reduction. So that's how we would do dilations in the coordinate plane. Thank you so much for taking these notes. All right, bye.